Hello, YouTube. So today, here I am with a topic. I'll be solving few more problems on shear force and bending moment diagram because this is one of my favorite topics. So I'll be solving few more problems on shear force and bending moment diagram. Okay. So I take this problem. A cantilever being 5 meter long carries point load of 30 kilonewton, 20 kilonewton, and 10 kilonewton at distances of 1 meter, 3 meter, and 5 meter from the fixed end. Construct shear force and bending moment diagram. Very easy, friends. So let me draw the diagram for you. So what is happening here? Cantilever one end will be fixed, other end will be this free. So this is a cantilever beam. Okay, one end is fixed. This is free. This is fixed, and this is free. So cantilever beam 5 meter long. The length is 5 meter. Carries a point load of 30 kilonewton, 20 kilonewton, and 10 kilonewton. 5 meter long. I have drawn that, shown that. 30 kilonewton, 20 kilonewton, 10 kilonewton at a distance of 1 meter, 3 meter, 5 meter from the fixed end. So from here, at distance of 1 meter, 30 kilonewton is there. At distance of 3 meter from the fixed end, 20 kilonewton is there. At the free end, that is 5 meter, it is, and it is 10 kilonewton. Point load is acting. That's what is the diagram all about. So this is 1, 2, and 3. So here this distance is 1 meter, and this particular distance is, if it says 3 meters, so this particular distance will be 2 meters. So this is actually, yeah, 30 kilonewton. So that is actually 30 kilonewton, and this is 20 kilonewton, and this is 10 kilonewton, and this is 1 meter, and from here, from fixed end, it is, here this is 3 meter, and 5 meter, it is at 10 kilonewton. So what is that, students? So 30 kilonewton is the distance of 1 meter. 30 kilonewton is the distance of 1 meter from the fixed end. 20 kilonewton is the distance of 3 meters from the fixed end, and at 10 kilonewton is a distance of 5 meter at the free end. That's all about the diagram. Now we'll try to solve the problem. Okay, so is that clear, students? That is the question all about. So next. So let me draw the diagram once again. This is, try to understand the problems, students. So it is So this is 30 kilonewton, and this is your 20 kilonewton, and this is your 10 kilonewton, and this distance is 1 meter, and this distance is 3 meter, and this distance is total length of the cantilever beam is 5 meter. So what do we say? If this is from here to here, if it is 3 meters, and from here to here it is 1 meter, then 3 minus 1 is 2. From here to here it will be 2 meters. And if total length is from here to here, it is 5 meters, and from here to here it is 3 meters. So this particular is 5 minus 3, which is 2 meters. So is that clear, students? Okay. Now, how to solve this problem? So that is 1, 2, 2. So here previously 1, 1, 3, 5. So I made it as here 1, 3, 5 from the fixed end. So I made it as 1, 2, and 2. And 30, 20, 10 are the kilonewtons are the loads, and 1, 2, 2 is the distances at which the point loads are located. Now let us try to solve the problem. Very simple, students. So how to solve the problem? So let us get into the problem. Yes. So very simple. So what we do, we'll try to resolve the forces like this, student. Yes. Like this. Yeah. This particular force will be acting like this. So we'll try to name this however you want. This is your A, B, C, and D. So this is, we have, when we resolve this, R reaction R, vertical A, vertical reaction at A, horizontal reaction at A, vertical. So this is the forces acting. Now the thumb rule is, what is the thumb rule, students? You have to know the thumb rule. So thumb rule, if any force is, yeah, here what we observe from the diagram is, from diagram, RAH is equal to 0. Why it is 0? Because this force is acting, RAH is acting towards the left, there is, which is horizontal. There is no other force which is compensating to balance that particular force. So we say that RAH is 0 from the diagram. Now before getting into the, now to solve the RAB, what we do, upward force is equal to downward force, or else the forces which are going upwards are taken as positive, and the forces which are going downwards are taken as negative. Okay, so we'll write it as also from diagram, RAV, which is going up, upward force are positive and downward force are negative. That is the symbolic convention for cantilever beam, the sign convention. Okay, students, that is the sign convention for the cantilever beam, for the shear force, also for any reactions, also any reactions I meant. Okay, so capital RAV will be plus, because it's going up, and this 30 kilonewton is coming down, so it is plus 30 minus 30 kilonewton, and this 20 kilonewton at C also is coming down, so minus 20 kilonewton, and minus 10 kilonewton, that is also coming down. Okay, or else we can also directly say that upward force is equal to downward force. Sum of upward force is equal to sum of downward force. So RAV equals 30 plus 20 plus 10. That's how it is balanced. You can choose any of the equations, whichever you find it very simple, students. So okay, that's what I want to say here. Ultimately it should be like very, you can choose this or you can choose this, but both are same, but only difference is here. This will be equal to 0. Okay, okay, students, that will be equal to our 0. That you have to remember. Okay, upward force is equal to downward force. Okay, is this equation, and this upward force going forces are taken as positive and downward going forces are taken as negative. So when we solve this, what do we get, students? We get RAV is equal to 30 plus 20. 30 plus 20 is 50 plus 10 is 60. Total is kilonewton. 60 kilonewton. So this is 60 kilonewton. Okay, students, so this will take it as 0 kilonewton. Now we have found all the reactions. Now what is left now to find the, straight away get into the shear force diagram and the bending moment diagram. For that, let me draw the diagram again. Okay, so this will be, this time I'll take single. Can represent a single also. This is your 30 kilonewton and this is your 20 kilonewton and this is your 10 kilonewton. Okay, students, and this is at a distance of 1 meter and this is at a distance of 2 meters and this is also distance of 2 meters, and this is RAV, which is 60 kilonewton, and this is RAH equals 0. Okay, students, now we get into the drawing the shear force diagrams for this SFD calculations. This is very simple, students. As I already told you, whichever the force which are going up is taken as positive, whichever force is going down is taken as negative. So we'll go it like this. So we'll take like this. Do section like this at the points. So we can call this as A, B, however I want, C, D, like that. And this is at the D in front of right of D and left of D is will take section here also. So different colors I'll use so that it's better for your understanding, but it's only the section. Okay. Then okay, students, is that clear? Now what we'll do for shear force diagram calculations, so we'll find, as I already told, R A V to the left and R A V to the right, and R C to the right and R C left, and R B to the left, R first left and then right, RB to the right, and RB, RA to the left and RA to the right. So this is actually, okay, students, this is left and this is right. Okay, so what I want to say is that, okay, so this is your RAV. So this is your RAVL, and this is your RAVR, and this is your RCL. This is your RCR, and RBL, RBR, and finally this is RAL and RAR. Okay, students, so the corresponding in colors also, if I use this R, so yeah, if I write same corresponding colors, it will be easy. RAVL, and this is RAVR. Okay, let me finish this. RAVL. So what we'll do, we'll place our hand where RAVL is placed. So When I view the force like this, assume this is your RAVL section. I place my hand like this. To the, if I view to the to the left of that, because my left hand, I'll view to the left of that. If I view to the left of that, like this, left of this, okay, what is happening? There is no force. So we'll say RAVL is 0 kilonewton. Similarly, if I place my hand at RBR, so RAVL is, I have placed my hand here at this place, and RAVR, I have placed my hand here, RAVR here. If I place my hand here and view to the left, what is happening to the left? If I place my hand to the left, it is the force going up. If the force is going up, what is the sign convention? I have told already, plus 60. So directly I'll write plus 60 kilonewton. Now coming to your RCL. RCL, RCL, okay, and RCR, R, okay. If I place my hand RCL, what's happening? There's no other force to the left. There's only one force, which is 60 kilonewton, which is going up. So it will be added up. So it will be plus 60 kilonewton to the left. Place it like this and view to the left. RC. So that is RCL. Now I'm placing my hand at R, a section at RCR. I'm moving to the left. What is happening? There is one force going up, which is plus 60, and then force going down, which is minus 30. So downward force is minus. So plus 60 and minus 30, which is plus 30 kilonewton. Now coming for RBL, RBL and RBR. What is happening at RBL? If I place my hand at RBL, we see that one force going up, which is plus 60, and one force which is coming down, which is minus 30, which is same as this, the previous one. Plus 30 plus 60 minus 30 is plus 30 kilonewton. Plus 30 kilonewton. If I place my hand at RBR, what is happening? I see a force which is plus 20 kilonewton, which is going down. So plus 60 minus 30 minus 20. The summation of the forces takes place here. So that will be plus 60 minus 30 and minus 20. It is going down, those minus. That will be 30 minus 20, which is 10 kilonewton, which is at RBR here. Now, if I place my hand at RAL, which is same as the carryover force plus 20 kilonewton, which is going down, which is will be the same 10 kilonewton, which is at RAL. So 10 kilonewton, which is plus 10 kilonewton. Now, if I place my hand at R and view to the left, what is happening? One force going down, which is plus 10 and minus 10, which is 0 kilonewton. We'll just be adding up. Is that clear, students? So what is happening here? We are starting with 0 and we are ending it 0. Now draw this is the shear force diagram. Okay. Now this is with respect to the calculation. Now with this calculation, it's very simple. Now arams we can go ahead with the drawing the shear force diagram. So for that also, you need not actually draw multiple diagrams like this. You can draw one below the other, but for your understanding, making the diagram very clear and easy. Okay, students. So this is actually my cantilever. This is 30, and this is your 20, and this is your 10 kilonewton at the free end, and this is your 1 meter, and this is your 2 meter, and this is your 2 meter. So this is as usual. These points are important here. A, B, C, D. I'm going left here. So if it was like this, just change that to A, B, C, D. Okay. So with respect, actually, you can just take it like that. Okay, this one you can see I just changed it. I should have used here also ABCD itself in this lot, but I used like this. So if you want to maintain a like common notations, you can just keep it like this. This is A and this is also B, but not a big thing. Okay, friend. So I can actually go with this as A B C D, so that if it's I should go with A B C D only because I will write a little. Okay, let me just change it. Why to have a confusion around? Okay, it's better to change it, isn't it? So there is no confusion, student. That is most important here. Okay, understanding the concept is most important here. So this is here. Okay, and so what I want to say here, it is actually this is not A. This is your A. So as usual, this is your A, and this is your B, and this is your C, and this is your D, and this will be actually I start with this. Okay, so this has to be your B. This is B, and this is your corresponding C, and this is your corresponding C, and this is corresponding your D, and this is your D. Okay, so C, so C left and C right. Okay, so this will be B left and B right, B left and B right. So this is D left and D right. Okay, so this will be, and this accordingly A L A B R, and this will be R B L and R B R. So this will be R. This is R B L and R B R, and this will be as usual. This will be R C L and R C R, and this will be R D L and R D R. Is that clear, friend? Now it's very simple. Now let me go to solve the final, which is our shear force diagram. Afterwards, I'll discuss about the bending moment diagram. So remember, this is A, and this is your B, and this is your C, and the D. So what you do is very simple. Just drop lines like this, vertical lines, and after that, just draw one horizontal line. Now, how do we proceed? RAVL, it is 0 to 60. At A, it is 0 to 60. From here, it is rising to up to 60, height of 60, from 0 to 60. Then that is, yeah, what I'm discussing, 0 to 60. So 0 to 60. Next, it is constant at 60. Then at B, it will be to 30. This 60 will be constant here. So at B, it will be coming to 30. Drop. This is your 30. So, and again 30 at C, it is again 30, and it will drop to 10. This is your 10. Then 10 and 0 at D. This will be, and this will be 0. This whole thing is here is 0. So what is happening? Understand, students, from 0 to 60 at A. At A, from 0 to 60. At B, it is 60 to 30. At B, it is this, from here to here it is 60, from here to here it is 30. So 60 to 30. So I'll write this for 60 to, this is 30. At C, 30 to 10. 30 to 10. So at C, this is from here to here 30, and this is from here to here it is 10. So this will be again 30. And at D, what is happening, students? 10 and 0. 10 and 0. So this will be here 10 and 0. So what is happening? So we'll just locate it like this. So it is the required shear force diagram, which is positive. So corresponding A, B, C, and D. Is that clear, students? That is with only with respect to the shear force diagram. Now we get to the bending moment diagram. So for that we'll take separately as usual. So this is 30 kilonewton, and this is 20 kilonewton, and this is 10 kilonewton, and this is 1 meter, and this is 2 meter, and this is 2 meter. This is as usual A, B, C, and D. Now what is happening, students? For BMD calculations, clockwise is taken as negative. Clockwise is clockwise movement. This is clockwise movement is negative. If it is anti-clockwise, so this is anti and this is clock. So this is positive. So very simple. So here also we'll take, but at this particular thing, we'll be taking the section at the points like this, at the A, B, C, and D, like that. Okay, students. Now is the sign conventions. I have used, and here for shear force it was, this is the sign convention. So very simple, students. So what we'll do, BM, bending moment at D. At D there is only load acting, but is there any force? Bending moment is force into distance. Force is acting, there's no load. So we'll say 10 into 0. So it is 0 kilonewton meter. Bending moment at C will be at this particular point. At C, the load is 10 into, it is acting with respect to C at a distance of 2. It is going like this. So that is in what sense, students? That is your clockwise. Clockwise is negative. So minus 10 into 2, force into distance. So minus 10 into 2 will be minus 20 kilonewton meter. Now bending moment at B, that is at this point. So we have to go, it is also with respect to the summation 10 into with this with respect to B, so 2 plus 2. So that is also in clockwise. So 10 minus 10 into 2 plus 2, which is 4. So minus 10 into 2 plus 2. And with respect to the C, it is 20 into 2 with respect to. So this particular force 20 into this distance is 2, but that is also in clockwise. So clockwise. So that is also clockwise, means we have sign convention negative. So minus 20 into 2. That will get added up. Minus 20 into 2. Then bending moment at A will be minus 10 into, from here to here, minus 10 into 2 plus 2 plus 2 plus 1. So 2 plus 2 plus 1. And with respect to the C, 20 into 2 plus 1. That is also minus sense. It is going like this. Minus plus 1. And last one, 30 into 1. That is also going in what sense, friends? Clockwise. So clockwise is, we already discussed, it will be negative. Minus 30 into 1, which will get added up. Clockwise, which will get added up. So how much is that, friends? So this will be minus 10 into 2 plus 2 is 4, minus 20 into 2 is 40. So that will be minus 40 minus 40, which is minus 80 kilonewton meter. And this will be minus 10 into 2 plus 2 plus 1 is 5 minus 50. 10 into 5 minus 50 minus 20 into 3 is minus 60. And minus 30 into 1 is minus 30. So the answer is minus 110 minus 30 is minus 140 kilonewton meter. Minus 140 kilonewton meter. That is with respect to the bending moment at A. Minus, okay. Okay, students. So that is with respect to the bending moment. So bending moment at D, bending moment at D is 10 into 0 because there is no force acting, and bending moment at C will be, let's say, 10 into 2 negative sense minus 10 into 2, so minus 10 into 2. Then bending moment at B will be this particular thing at B, minus 10 into 2 plus 2 and minus 20 into 2 with respect to B. So it added up, and last bending moment at A will be minus 10 into with respect to A, minus 10 into 2 plus 2 plus 1 and minus 20 into 2 plus 1, clockwise is negative, and minus 30 into 1 with respect to A. So there lies the calc. This is what is important, students. And remaining things follows. If you have any doubt, don't forget to ask in the comment section. Okay, these things are simple. You can just do the calculations there on simplification, as simple as that. So this is what is most important, students. So now let us draw the BMD for that and finish the problem. So this will be 30 kilonewton, and this is 20 kilonewton, and this is 10 kilonewton, and this is 1 meter, this is 2 meter, and this is 2 meter. As usual, A, B, C, and D. So how do we draw? Same way, just draw vertical lines, the supports, and draw horizontal line. So what is happening? Bending moment at D is 0. So bending moment D is 0. So we'll start with 0. Then bending moment at C is minus 20. It's going down. So at C, so it will be minus 20 till here, down. And bending moment at B is minus 80. So still it will go down. Minus 80. And then this will be, my bending moment at A will be minus 140. That will be further down. 140. So it is all negative bending moment. So this at the D, C, B, A. This is your BMD. Okay, students. BMD, and this is your SFD. Right. So that is with respect to a single problem and solved. Any doubt? Don't forget to ask. Okay. Next, we'll move on with the similar problem. Okay. So Yeah, next. We try to solve one more problem. So one more problem goes something like this. A cantilever being of span 4 meter carries point loads of 2 kilonewton at its free end and 5 kilonewton at 1 meter from free end. Sketch SFD and BMD. So for that, students, as usual, I'll tell cantilever beam span total length cantilever beam distance here 4 meter. I've explained the previous problem very detailedly. Now I'll go a little fast. Cantilever beam span. If you have any doubt, ask me in the comment section. Carries 4 length is 4 meters. Point load is 2 kilonewton at its free end. So free end here it is 2 kilonewton and 5 kilonewton at a distance of 1 meter from the. So this distance is 1 meter. So 5 kilonewton is placed. So this particular distance will be 3 meter because 4 minus 1 is 3. So now you have to just plot the shear force and bending moment diagram for this. This is very simple, students. So as usual, what is happening here? Total length 5 kilonewton and this is 2 kilonewton and this is 1 meter. This is 3 meters. So A, B, C. So as usual, this will be resolved to R, A, V and R, A, H. So R, A, H is 0 horizontal force, there is no reaction. So R, A, V will be equal to upward force equal to downward summation of equation of summation of downward force 5 plus 2, which is 7 kilonewton. So this is your 7 kilonewton. Now for SFD calculations, so what we do, SFD calculations. So as usual, we'll resolve like this. Okay. So this will be, so let me use a different color so that it's easy for you to the sections. So this will be like this. Okay, and this will be just above, in front of and back of. So okay, so we have as usual R A V L R A V R R B left R B right R C left R C right. So R A V L is this R A V L R A V R R B L R B R and this is R C L and R C R. Okay, so R A V L. If this is R A V L, so if I place my hand there at RAVL and go to the left, there is no other force. So 0 kilonewton. If I place my hand RVR, so and go to the left, so there's a force which is going up. If I go to the left, the force is going up. Upward force is, I already told you, if it is going up, it is positive. If it is going down it is negative. So it is, we'll take it as plus 7 kilonewton. And RBL is also the same. There's no force acting to the left, so it will be continued plus 7 kilonewton. And if I place my hand at RBR and go to the left, there is one force going down. So plus 7 and minus 5. Plus 7 and minus 5 because minus 5 because it's going down. Plus 7 minus 5. So plus 2 kilonewton. And RCR also it get like added up there. The same. There's no force further, so it will be the same previous one, 2 kilonewton. And RCR, if I place my hand there, 2 kilonewton going down. So plus 2 and minus 2 will be 0. Is that clear, students? Now that is with respect to the reactions. SFD reactions now to draw. So this is 5 and 2. Okay. Okay. 1 second. And 5 meter from the free end, 5 meter, 5 kilonewton. So this is actually 5 kilonewton and 2 kilonewton. So this is 1 meter and 2 meter. Okay. Okay, students.